Thank you for joining us and taking time out of your busy day. And I hope you're as excited as we are to be here to present to you guys. So, looks like we're going to be launching a poll here just to kind of get to know who's attending today. We're grateful that you're here with us.
Hold on a sec. We're just going to do the agenda there.
Okay, so I'm missing the agenda. I thought you were covering that. Yep, Giver.
Yeah.
So we've got, we're going to be working with FME Desktop and FME Server for Smallworld. We're going to be covering working with versioning and alternatives. CAD to GIS demo. We got a database replication demo. And we're going to cover off some schema mapping and dynamic workflows. That's going to be really good stuff. And then hopefully we're going to have time for that self-serve data download at the end there, Mark. Is that right?
I hope so. And, well, or during. Actually, yeah. And we've also got a bonus. If we don't go over time, we've got a bonus demo on location intelligence.
All right. Okay, so now we're ready for that poll question. So Stephanie is going to launch that poll for us. So have you used FME with GE Smallworld? So we got a few selections there. So if you can run through there, everybody's please submit your answer. That'll greatly help us understand who we're presenting to today. A little bit of tidbit of information on Smallworld. They were one of our earliest partners here at SAFE. A group in Denver developed the first Smallworld reader-writer. Smallworld 2.2, we think it was. So,
yeah,
right.
That was a long time ago, and that was still in the old mapping file days of the FME. So that was pre-Workbench. So that was a big struggle for people to get data in and out of Smallworld. When in those days I had to write the mapping files to generate that, and then we moved on to Workbench, which has made life a lot easier.
All right. Okay, so did we shared the poll there and we had the top one. We didn't really talk about that. Steph, you want to bring that up again? So okay, so we got 42% of the audience is used all the time. Okay.
Okay, so that's good spread. So we've got a good experienced group today, so that's nice to know, because we are going to be flying through some of these demos. Just a small group that haven't used FME much in the past.
And out of curiosity, if anybody that's used that Smallworld 2.2 reader-writer, just raise your hands there in the dialogue. That'd be great to know. Okay, so please ask questions. We've got Mark and Ken standing by. Ken's over in France, so he's like near his bedtime, and we're well, I shouldn't say bedtime because it's probably 5 or 6 over there now. Mark Arlen in Central Time Zone. He's been up longer than us too, so they're all hot, ready to go. The webinar is being recorded, so you'll receive an email with a link and the recording and all the example workspaces after the fact. All the examples are based on the ubiquitous Cambridge database, so you guys will probably have access to that. All right. And we don't have our arrows on our screenshot there to see so who's there. So if you happen to be new to FME, and there was a few of you, please stay with us. It's going to be a moderate level technical webinar here, so there might be some things that you may not quite get, but that's quite all right because stick with us, and after the show is over, you can go visit these two great resources online and get going on FME. Hopefully we've raised your energy level enough after the presentation that you're all excited about looking into the world of FME as well. It's going to reduce your stress level, although that's not medically proven, but we do believe here at Safe Software we got a great product and it helps increase your productivity. All right, so let's get going here. We got another slide coming up. All right. So we have... Yeah, give her.
So just an introduction to the Smallworld readers and writers. There is, Smallworld's one of the more complex of the formats that we support for a number of reasons. Its power of its virtual managed data store and the multiple geometries, but also the large number of versions that we've supported over the years. And so there are two primary offerings for Smallworld if you want to get data in and out. There's the reader and writer that comes from GE themselves. It's called the FME Translator. It comes on a DVD. You have to get that DVD from them. but there's no cost for that from them. It supports a wide range of the versions. So you do have to make sure you've got the right version of the FME translator to work with that. I'm working with Smallworld 4.3 today, and I'm using FME 2014 with that 4.3 reader and writer. The Smallworld guys are always a little bit more conservative, so if you ask them what version of FME is compatible with their reader and writer, they'll probably always tell you an older version. I'm not quite sure what the current version is, probably FME 2012 that they would suggest, because that's one that they've done their validation on, but we would always encourage you to move forward. And you can install multiple versions of FME, so if you want to test the latest FME against any workflows that you already have, then you can do that, install a couple of copies of FME, your production copy and a test copy of FME 2014, and then you can move forward with the new system. And then there's a second read and writer available from Spatial Business Systems. They've built a plugin for Smallworld. It's a little bit more advanced, I think, than the GE Smallworld one. Has better support for more complex joins than the GE one. So really, whether you need to move to that reader and writer will depend on the level of sophistication of your data loads and extracts. And also, the Spatial Biz reader and writer is very much tuned to data replication, especially to Oracle databases. So if that's kind of an interest to you, then you might want to have a look at that Spatial Biz reader and writer. There is an extra cost to getting that. There is also the Smallworld SOM for FME, and friend Alfred Sawatsky, who's been a long-term Smallworld and FME user, made a little video on his blog, so that link will go out with these slides so that you can find that little video. If you want to learn more about that SOM for FME, essentially it just extends the format reach of the Smallworld SOM. Okay, well, let's get going with the first kind of introductory look at FME and working with Smallworld data. So one of the nice things about the newer of the Smallworld reader and writers, which I think, Steve, I think this was kind of introduced around 4.2, I think, the newest Smallworld reader.
Yep.
Makes it very easy to work with versions or alternatives, and also checkpoints, and has a database connection service so that you don't have to have the Smallworld GIS running, which makes the whole thing compatible with our FME server product if that's appropriate for you. So let's have a quicker look at using Data Inspector with the Smallworld reader and writer. Just one thing to remember is at the moment the GE Smallworld reader and writer doesn't dig out the coordinate system that your Smallworld system is running in, and that's the world coordinate system generally. So always remember to include the coordinate system when you're working with this guy. All right, so here's the data inspector, and so when we look at some Smallworld data, we get open up the reader there, and then we've got the parameters as usual on most of the readers and writers, and there's a couple of things you can change here. So the FME service, there's two options here, FME no factory, and you can also put in just FME. And this tells the Smallworld reader whether you're going to preserve the multiple spatial columns in Smallworld or whether you're going to split out the spatial columns and break those into separate features. So if you have a location and an annotation, do you want to columns? Do you want to keep one feature with those two spatial columns, or do you want to split that object into two features, one with just the location and one with the only the annotations? And then lower down here, we've got the options for working with alternatives. So we can work with an alternative here. So I've opened up the FME alternative. And what's a great feature with the Smallworld Reader and Writer is that you can export deltas or changes from a baseline alternative. So let's just look at the Smallworld GIS that I've got open here and just have a quick look. So this is all the data we're working with today is from the Cambridge database, and I've added a couple of extra features into this FME alternative. Just a couple of properties here that Safe Software folks are going to try and buy up down at the bottom there. So those have been added to the FME alternative. And then, so if we read from that alternative in the FME world, we'll see those additional features. And okay, so there, right there, I forgot to add the coordinate system. So we're not getting a background map. So that's why it's useful to remember to include the coordinate system, because then you'll get a background map. I've got to try and follow my own advice here.
Another thing too, Mark, we're looking at the FME Data Inspector for those new to FME. This is a visualization tool that can interpret or read all the formats that we work with. So.
Yeah. Thanks, Steve. Yeah, that's absolutely right. So if you're asked to load some AutoCAD data into your Smallworld and you don't have Autodesk products on your machine, you can look at those data sets. Okay, so I'm just clicking on one of those added features there, and you can see that's come through from that alternative. These are the new features. The proposed ones are the new features, the cables in this case for that feature. Okay, so if I now continue with that and I go back to the parameters, and now what I do is I say I want to export changes from baseline, and that's going to be the top, so that's just a pipe symbol there that represents the top. Notice here that we can use a search envelope, so if I had features outside this search envelope, which is in the world coordinate system, which is in millimeters for Smallworld, that's what we're going to get. So now I'm asking for differences only, and there we have them. So those are the features are different between the top and that FME alternative, and that can include any deletes as well. If there were deletes between those alternatives, we would get those. What's very nice here, though, is note that there's a column here, the FME DB operation, and that is kind of an internal attribute that FME can use for incremental updates between databases. And in this case, they're all set as inserts because they're all new features. But if we were doing data replication, which we're going to do a little bit later on, if you set this FME DB operation, each record knows what's going to happen, whether it's an insert, update, or a delete. And so that option here that we had, export changes from a baseline, when you put in a baseline alternative, automatically populates that FME DB operation for us, so the destination database knows whether it can do an insert, update, or a delete. So that's pretty cool.
Yeah.
Okay, just so there we are, going back to the original data. Now what you'll see is as I'm working around in here, if I click on one of these features, let me just zoom in a little bit more. There, I've got the supply point. Now a supply point is a multi-part geometry in the Smallworld, so here we can see that we've got two geometries, the text location and so that would be the annotation in the Smallworld, and we've also got the location object, which is the actual location of that supply point symbol in the Smallworld GIS. And so if we were to look at that equivalent feature in the GIS, we could probably select one of those and then have a look at the editor. You could see that the location and the label have geometries, and so that's what we're preserving. In most cases, if you're exporting Smallworld out to shape or something like that, you probably don't want to do that, and that's why we have this second option, which is called the service, and you would just replace that, which is actually the default to FME, and then what will happen is that all the geometries will get split out independently, and they will each have their own feature representation. So typically, if you're going out to shape or simpler data GIS format, that would be the approach you would take. So we could zoom in here a little bit again, and text doesn't always come out perfectly in FME, but you can see now that this text object that I clicked on, there's only got that one geometry on it, and the service point itself, the supply point itself, has been given a separate geometry. So typically, if you're going out to a simpler GIS, not a multi-spatial column database, you would use that FME factory. Sorry, just the FME option instead of FME no factory. It is a weird name. It's kind of historic. Underneath the covers, there's a very old function in FME called the Smallworld Geometry Factory. So that's where this name seems to have come from. So FME no factory if you want to preserve the spatial, multi-spatial column nature of your Smallworld data. Service FME if you just want to split out the geometries into separate objects. Okay.
Yep. Some flexibility there because a lot of formats aren't going to deal with those multiple geometries like Smallworld does.
Definitely, yeah.
All right.
Okay, well, this is a very typical use case for FME, but actually it's a demo that I'm just going to skip over today. I'm going to ship with the webinar materials that you're going to get at the end of this webinar, the workspace that we created to do this. But loading CAD data into GIS is a very typical workflow. Fits very well within FME Server. But on our FME Server, on our FMEpedia website, there is a live demo, which is very similar. It's not loading data into Smallworld GIS, but that's a much smaller part of the problem, so that people who are watching today can go there, download the workspaces as well, and actually run this demo live. So we're going to skip this demo just for the sake of keeping things moving. But the key part to loading data, CAD data especially, into GIS is the validation. So often that includes connecting text and or annotations in the CAD data to line work or symbols. Geometry validation, you can use the geometry validator, attribute validation, and you can also validate network data, and we're going to have a look at that in a separate demo today. So, so that's an example there waiting to be looked at for loading CAD data into GIS. Very big part of, I think, our Smallworld users doing that. Okay, so extracting CAD data from the Smallworld database. So obviously the first thing is to choose the right CAD format you're working with. If you're working with MicroStation, obviously you've got to choose between whether you're working or your customers are working with version 7 or version 8. AutoCAD is even more confusing. We've got just native AutoCAD DWG. Some people might still be using extended entity data there. You've got AutoCAD 3D Map, which is much stronger more GIS-like in terms of preserving attribution. That's the CAD format that I generally use. Civil 3D, plus as well, you've actually got the AutoCAD version that you might have to support, might be an older version, so you've got to work through all of that. And map info as well, I believe. We've got the DWG styler transformer and the DGN styler, so they help you connect blocks or cells to your objects, help you style, create line styles, and so on. And then we also have the concept of templates. Well, we call them templates for AutoCAD. Actually, I can't remember what we call them for MicroStation. What are they? Seed files or?
MicroStation seed files, yeah.
Yeah.
Maybe seeds.
And so they have the predefined symbols and layers and
cells,
so on. So I wonder if I've got a workspace here that I can open up.
Cell library is the other part of those symbols too, right? Yeah.
Yeah. So typically, what you might do is do some labeling. So this is reading from the Smallworld data store. You might want to create new labels depending on whether the label locations in Smallworld line up with where you want them in the AutoCAD. The AutoCAD styler allows you to use this template file, and then from that template file you can choose what line type you want to use that might be in that template file. So a template file in AutoCAD is really just an AutoCAD drawing, an empty AutoCAD drawing where all the line types, blocks, and so on have been predefined. And then you can run and extract, have a look at the results. But the great thing about this is where this would be a very good use case for connecting to FME server, and we could upload this workflow to, in my case, just a local FME server.
Mark, it looks like you're trying to put together a little scenario where people can actually go and pull their own data down instead of the GIS person doing the extracts. Is that what we're seeing?
That's exactly right. Yeah, absolutely. So we could publish that up to server, and a couple of quick steps there. That's gone up to the FME server. So if I now go to any web page, I can open up my FME server. Now, typically, people will brand these web pages as their own. These are the default web pages that we ship with the FME, but you can see in that previous data upload demo that we've hidden the actual web pages of FME server away a little bit. I'm going to run this one that I loaded up earlier. There might be a few configuration parameters that you want to that you have to work with, and then you can run the workspace. So this is where somebody can start to do some self-serve data downloads instead of, as Steve says, pestering the GIS users.
Yeah. And the other nice part about this here with FME server, you could create, like you alluded to, a custom interface, and those parameters that we're looking at there could be drop-down boxes and that sort of stuff, and that could be very easily programmed, pulling information from the workspace if you could set up option lists on, say, the coordinate systems that you want to go out to and that sort of stuff.
That's right. And in most cases, this would be delivered back to you. Rather than asynchronous, it would be delivered back to you as an email. And here we can see that we've got the, should have said open. Here we've got the zip file that contains that resulting AutoCAD dataset. There we go. So that's the downloaded AutoCAD dataset. Now, just going back to look at those parameters that we had there, so this is where this would typically tie in very nicely with a nice web mapping tool, maybe the SIAS or the equivalent in Smallworld, so that you would be able to draw your own bounding box instead of just typing them in here in a bit of a plain web page, a web form. So you could have this integrated into a nice web mapping environment, draw a bounding box, and that would be the region of interest that you would code for this CAD extract.
And yeah, and another thing to note there on those published parameters, those are actually coming from the workspace. So we've exposed those in the workspace. When you push an FME server, now you have access to let your users manipulate those parameters as well.
So pretty well any of the demos that we've got here today could be published up to the FME server. This was a big advance with the newer Smallworld Reader and Writer. Both the GE Smallworld and the Spatial Biz Reader and Writer support this idea that you no longer need to have the Smallworld GIS running, which really opens up automating your Smallworld workflows now through FME server, if that seems to be appropriate. I mentioned that you can do network validation in FME as well, and so I've got a very short example here that we can look at. So this can be done either during the data load, or it could be done after you've done the data load to look at the results and make sure that the data that you loaded in has actually loaded successfully and that they do form a contiguous network if you're adding additional features. So here I'm just reading the cable data, and that includes those proposed cables that we added in the FME alternative. And then a key part of this is the network topology calculator transformer in FME, which sort of builds the networks and sees how the network is constructed. And then what I'm doing is I'm testing to see whether features are on a major network or whether they're kind of hanging out by themselves. So I can run this. And what we'll get, in this case, I'm pumping this out into a KML data set. And again, this would be a great target for FME server, because you'd be able to automate it, and then you'd be able to open up, stream this data directly to Google Earth and open up Google Earth right away. And so over we go to our Cambridge database, and you can see here the blue is the proposed network, which in my model means that it is nicely connected. The cyan, sorry, is the proposed, but it means that it is nicely connected to the major network. And the purple objects here are those disjoint cables that don't really connect to any other part of this small Cambridge network. So you can start to see whether your network data does line up if you're doing data loads or you're validating CAD data as into your GIS.
Yeah, and that ties back into another way we could be looking at this by having contractors and such email in CAD files and have them validated before involving anybody on the GIS side. Report back to them any of the issues, and then obviously make those changes, and then maybe submit them back, and possibly even load them into a temporary version or a version that can be then reviewed by the GIS and loaded into the main system. So pretty neat stuff.
That's a really good point there, Steve. And so actually that CAD data loading example that I was mentioning earlier on, there, I think that one does that. That's an email in, so you can, when you run this live demo, you can email in these CAD files. And I'm just going to try and stop this phone here.
We got a little phone ringing in the background, so yeah, keep pouring in the questions there, team. Anybody out there in the audience? We're if you've got anything that pop up, don't hesitate to bug Mark and Ken with some questions. And even if they're really, really difficult and we can't answer them online, we'll get back to you after the webinar. So.
Yeah, sorry about that. Anyway, so this is an email in, validates the data, so that's a really good. And the thing I was just going to add there, Steve, to what you were saying is that the reporting of the errors is very, very important. So that's a part that FME can play there. And in this case of this example, you get a very nice email back with all the errors and the location of the errors. Okay, so working with CAD data, loading CAD data into Smallworld, extracting CAD data, validating CAD data, all very strong parts of FME, and hopefully you can use those as you go. All right, so moving on. Database replications. So this seems to be a very common task for Smallworld users. So I think typically people are replicating into Oracle. The Spatial Biz Smallworld plugin has been fine-tuned to do this kind of work, but you can do it with the GE Smallworld Reader and Writer if that's the one that you have. A big part of the database replication is preserving the multiple spatial columns, so you can do that if you're going to SQL Server, Oracle, or even PostGIS or something like that. And then there's typically two steps in the database replication process. The data load itself, and then the ability to do incremental updates. So let's have a look at how that looks. So let's go back to a workspace here, move on to our next demo. There it is. So bit more of a complex kind of workflow here, and not in terms of the actual data transformation, because here what we're really doing may or may not be the case, is we're doing a mirror really of the Smallworld. In this case, I'm going off to a SQL Server, but it could just as well be Oracle. So not doing a lot of schema manipulation here, but there is still a fairly large amount of detail in the workspace. The first thing is that we're using the service FME No Factory. So remember what that does. That preserves the multiple spatial column nature of your source Smallworld database. Then on the SQL Server database writer that I'm using, if you're working with multiple spatial columns in any of our databases, you have to use this parameter that tells the writer that it is working with multiple spatial columns and not just a single spatial column. So that handle multiple spatial columns parameter is available on all our database writers, Oracle, SQL Server, PostGIS, and so on. And that tells us we're going to be working in this special mode. Then there's a transformer that you can use, which we call the geometry property setter. And that sets the name of the geometry, and that's essentially telling FME the name of the geometry is the name of the spatial column that you want to insert this particular object into. And so that's how you can use that. In this particular case here, we've got the SQL Server executor. Now, one of the restrictions in FME is that you can't create tables with the database writers that have multiple spatial columns. That's not actually that common anyway. If you're going to be doing data replication, you're going to have a system administrator created those data typically. But if you do need to create those tables on the fly, you can use the SQL executor. So here's the SQL calls that you would need to create these tables with multiple spatial columns. So here you can see you've got the electric supply point, got the label geometry, as well as the location of the supply point. So those are the two spatial columns for that particular object. And that's about it. So then what you're going to do is to run the workflow. So I've got, whoops, not that guy. I've got the SQL Server Management Studio up here. We've got our database ready to go. So I'm just going to run this workspace. I've published some of the key parameters that we need here. So my first workflow is going to be doing a data load, and so I'm going to say if the tables exist, yeah, I want to truncate the tables. Otherwise, my SQL executor will recreate them for me. My writer mode is set to insert, and the source alternative I'm using is the top. So off we go. We're going to create those tables and load them up with the objects from that Cambridge network. Back to my SQL Server Management Studio. Let's just do a quick refresh here. So here are the new tables that we've added. Let's have a look at the supply points. So these are the supply points that have come in from that Smallworld data store, the top alternative, and we've got the label column and the location spatial column that have been happily populated. Okay, so that would be your first seed of your database. So now you might want to publish this up to FME server and automate this task, but now what we can do is we can run this in increment mode. We might be working from an alternative. So what we're going to say is, no, we don't want to truncate the tables. Yes, we want to do some updates. Our source alternative is going to be the alternative where we have the new objects that we were adding. We could add a checkpoint in here if you're working with checkpoints in your Smallworld database. Yes, we do want to export the differences from the baseline alternative, and that baseline alternative is the top, which is just a single pipe. Click OK there, and then we're going to do those incremental updates. You can see that we've got far fewer features on the feature counts come across here. Let's just get rid of a couple of these. And you wouldn't think that on such a remote island there'd be so many calls and buzzings going on, but there we go. Okay, and so what I'm going to do is I'm going to select the top few rows of this guy, and hopefully down at the bottom here we will see the couple of new entities that we added, which are the three new supply points, and the same for the cables and so on. We would have with those two spatial columns populated the label and the location. And of course some of these can be null, so if you don't populate a geometry, that would be fine too. Okay, so fairly complicated workspace in terms of some of the configuration, but otherwise we can do both the data loads and incremental updates across from Smallworld to another database relatively straightforwardly. Yeah. And I think there we're going to take a short pause to see if there's any interesting questions. We're going with Steve.
Yeah, there's one little bit of housekeeping there related to the workspaces. Someone's asked about that. These will be provided afterwards. You'll get an email with a link in it. We've got another person that's asked a question related to making joins. So for instance, they got a cable, a fiber cable, and they got a geographic area. So could we within FME make that relationship tie and then enter it into the Smallworld database?
Yeah, so with the GE Smallworld Reader Writer, I think that just supports reading and writing simple joins. So those are joins that do not go through a join table. So in the Cambridge database, the supply points and customers are linked through an intermediate join table. We can view those intermediate tables in FME, and actually you can extract them. It's one of the parameters on the reader. If I can bring up the inspector here, you can see that there's an option here, expose internal tables, and that would allow you to see those internal tables, which are the intermediate join tables. Where are those? I think if we just search for int, they will come up somewhere with the electricity. There it is. So that's one of the intermediate join tables there, I think, or something like that. I know there's one for the electricity, but I can't see it right off the top.
There it was, yeah.
So that's simple joins. I know the Spatial Viz Reader and Writer has got a lot more strengths there in terms of more complex joins, including multiple using intermediate join tables. So if that's a big part of your workflow, you might want to just talk to the Spatial Viz folks to see how they support that.
Awesome, okay. So that's some pretty good stuff you were showing there, Mark. The graphical interface allowing users, FME users, to really cut down on that development time and creating some customized workflows without using, traditional development methods.
Absolutely. Okay, so we're going to now talk about sort of a slightly different way of using FME. And that's around this concept of dynamic workflows. So dynamic workflows and schema mapping go very closely hand in hand. So schema mapping is the process of up the data from source to destination, and this is a big job that most people underestimate how long it's going to take. It's got nothing to do with FME at all, actually. So if you're going to move data from Smallworld to a CAD system, or from Smallworld to another database, maybe a public database that you want other users to look at, and so on, you have this task of doing the schema mapping, which is to say, okay, if I have a layer in AutoCAD, what object is that going to go into in Smallworld? And so you have to build up some sort of a table, sometimes called a crosswalk table or schema mapping table, that tells you how the data maps between the layer to the collection in Smallworld, how you might be renaming attributes or restructuring attributes, maybe setting default values if the data doesn't exist in your CAD data, maybe mapping descriptive values in a CAD data set to enumerated lists or domains in your Smallworld database. So there's a lot of transformers that you can use for this schema mapping task. It's called, there's one, the attribute renamer, attribute creator, which does attribute renaming or copying, as well as allowing you to set some conditional values, which is very powerful. Attribute value mapper, which is a great transformer for doing enumerated lists. And that's fine. You can use those transformers, and that's a very good way to do schema mapping, but it does create large workspaces with a lot of repetition. So we have another kind of schema mapping transformer that is called, funnily enough, the schema mapper, and that allows you to do this schema mapping. Here I've got an example on this slide, that instead of doing it individually by transformers, you can do that in a spreadsheet. And one of our colleagues, Brian Pont, has just, whoops, so that's supposed to be a link, but it's not working, has just updated our FMEpedia web pages with a brand new set of schema mapper articles, so you can go to FMEpedia and search for Schema Mapper, and you'll find those. So if you want to learn more about the Schema Mapper, we're going to have a quick look at it in the next step, or in this demo. So then the next part of that is how that relates to what we call dynamic workflows. So by default, when we've looked at any of the workflows that we've had in so far, you can see that FME is kind of very tightly bound to the schema of the source and destination objects. You kind of have to list out the target layers, in this case going to AutoCAD, what source objects you're coming from in Smallworld, what all the attributes are. So basically describe in detail the data model that you're working with on the source and destination side. And sometimes that's a little bit inconvenient and creates very repetitive workflows. So FME has this slightly different approach, which we call the dynamic workflows. So why go dynamic? Well, it makes your workspaces a lot easier to maintain. Workspaces are very flexible, so if something changes either on your source data set, i.e. you add a new object, or the attributes on an object are changed by your database administrator, FME can handle that without a lot of updates. And also what is great is this ties in very well with the Schema Mapper transformer, so that's where that goes. And of course all this ties in very well with FME Server, so you can publish these dynamic workflows up to FME Server, and you can then automate them.
And
so
nice
this workspace
is the nice thing about both of these things, though, is you really can save yourself a lot of effort once you get familiar with them and using them. I really want to stress that they're quite daunting when you get going on them to start with, but if you master it, it's going to make your life so much better working in FME with those kind of workflows.
Absolutely, yeah. So if it works for you and you can get it experimenting, then that's, yeah, absolutely, Steve, that's absolutely right. Make your life, in the longer term, a lot easier. And really the hard part actually is the schema mapping process here. So this workspace here that I'm illustrating here, that I'll bring up in a second in FME Workbench, is a dynamic workflow. It's the equivalent to doing that Smallworld to CAD extract, except you can see that there's only one source feature type, one destination feature type. We've dropped all the multiple DWG stylers and any attribute renaming tools, and they've been replaced by a single schema mapper. So let's go and have a look and see what that looks like. Here's a workbench. So yeah, so essentially what we're doing is replacing all these transformers. So let's go and have a look at what that might look like. That's the workspace. Let's have a look at what this, for this particular workspace, what that schema mapping table might look like here. And then I'll just walk through the workspace quickly. So what we're saying here is extracting from Smallworld. These are the Smallworld objects that I'm going to do the schema mapping for. If I decide to add another attribute object that I want to work with and export out to my CAD data, I don't need to edit this workspace at all. All I need to do is add a few more rows to my crosswalk table here, and those features will be mapped out successfully. In this case here, the main part of the schema mapping is renaming the source objects into a naming convention that more or less follows the National CAD standard, which seems to be very common for people doing design work in AutoCAD. So the object names are being renamed into layers that more or less follow this National CAD standard. Then I've got a few other AutoCAD-like attributes I'm setting. These are essentially the attributes that are set in the DWG styler. So this is where you would set what AutoCAD symbol or block is being set there. And so just working through this workspace, again, the actual configuration can be a little tricky, but once you get to understand it, it works pretty well. One of the key parts of this workflow is something that's buried way down here, but when you create these dynamic workflows is this parameter here called the feature types to read. And this dynamically reads the objects from your source database. Whoops, looks like I've lost my connection. But so that's where this workflow becomes very flexible. You can dynamically read the objects as you go. We've got the Schema Mapper transformer that is reading the schema from a crosswalk table that I've just shown there. So that's where most of the schema mapping is done. And then we've got what we've called a dynamic output feature type. It has this special parameter set here, use dynamic properties. And in this case here, what's happening is the schema for my AutoCAD data is coming from a table that we call the, in this case I'm calling the AutoCAD schema table. And that's, we can just open up that briefly. Basically, that's a table that tells us what attributes, what layers we're going to have, and what the data types are on that particular object. So for the cable, I'm going to call it that's the AutoCAD layer name, and these are the attributes that I'm going to create on that particular layer in the AutoCAD data set. And that's driven by something in this workflow that is called the dynamic properties, and then what we call the schema sources. So let's see if this thing will still run. It looks like I've lost my connection. Oh no, that is running. Yeah, that's good. And so just to recap, this is really the equivalent of that very first workspace we were looking at that had the multiple schema, DWG stylers and so on. And so we can just go and have a look at the results of that. That's that AutoCAD file, and I can double click on that and it'll open up in TrueView. Actually, this is something interesting here that FME supports. Whoops, I've lost that now. Then maybe I'll just point out while we're looking at that. And it's, dare I say it, something that Esri introduced, but FME supports, and so anybody can take advantage of this, is that if you add a .prj file, which is really just the shape format PRJ file, and you call it Esri CAD, or you give it the name of the file, this will tell you what the coordinate system of this data set, AutoCAD data set is. So that's a handy thing. If you have AutoCAD files where you know that they're in a good projection, if you just drop a projection file into the folder where those AutoCAD files are, FME will understand that projection. Okay, and there in AutoCAD TrueView is the result of that AutoCAD translation. Okay, so that's a quick review of dynamic workflows. Really recommend people check that out and have a look at that.
Yeah, I do too. It's a very good thing to learn about.
And so Brian has updated the schema mapping articles using the Schema Mapper transformer, and we're just in the same process of updating all the dynamic workflow articles on FMEpedia, so that's very timely with this webinar. So if you feel that that workflow will suit your needs, have a look at those articles. Okay, so I think we have time for a little bonus demo, which is about location intelligence. So this is a bit of a contrived example. So what if the Cambridge Electric utility there, they decide that they want to do some major updates on their substations. There's 2 substations associated with this Cambridge data set in the Smallworld database. So they're going to do some long-term maintenance there, and the union wants to know if there are any public WCs close to these Cambridge substations, so that if they have to take a toilet break, they can walk to a public toilet. Otherwise, we're going to have to install some Jiffy Johns at these substations while people are working on them. So WC is water closet, which is the Old English term for a toilet. So we're going to do some location intelligence on our substations and find the public toilets that are close to these substations and put out some sort of a report on that. So we've built a WC Finder workflow, and so within the location intelligence kind of arena that FME can work in, some of the things that we can do there are to merge in different data sets. So that's a very strong part of FME. You can take data from different formats and merge them together. We've got tools where we can tap into many different web services. So in this workflow, we're doing that. We're building service areas. We can do some simple spatial analysis, in this case match points with polygons, and we've also can tap in some web services such as Shortest Pathfinder and so on, and then we can produce a PDF file if we want to do that. So let's see what that workflow that does that kind of work would look like.
Mark, last night when I was looking at reviewing these slides again, I got an idea for like a great mobile app, and I went on the App Store just to see if there was anybody else out there that had a great idea. And you know what? Lo and behold, there was 3 apps created for locating washrooms. One of them was for London.
Right. There
you go.
Yeah. Yeah, you never know what's. There's always somebody thought of the idea before us. That's the sad thing.
Yeah.
Okay, let's just zoom in a little bit on my workflow here. So merging disparate data sets. So that's a very strong part of FME. So I am reading from my our Cambridge database here. So here's the location of the substations. They're coming in British National Grid millimeters, so I'm going to reproject those to a lat long because that's where the other source data is coming from. The substations do come in as polygons, so I'm using the center point replacer here to convert that polygon into a point so that we can do the appropriate analysis on it. So that's the first step. So the other data that I'm reading is coming from the City of Cambridge Open Data web page, actually, and so it's just an XML file that they've got up there that has the locations of the public toilets and the kind of the status of those toilets, whether they have somebody sitting there, what time they're open, and so on. And so actually, instead of having to download that XML file and then process that, FM can actually read that directly from the web page, and so that's what I'm doing here. Hopefully you can see that. So you can see here I've got an HTTP to the Cambridge Gov website that's pointing at that data XML file that's up on their website. So if they ever go ahead and close a public toilet for service or add a new toilet, we would get that live right off their website for this spatial analysis we're doing. So that's kind of interesting part of FME, that we can read this data live from a website. Okay, so some of the web services that we're using. In this case, it's a custom transformer that we've built that just uses, in this case, the ArcGIS online services for the service area calculation. So they've got that you can make if you're an ArcGIS user or you have a subscription to ArcGIS Online. And what these do is they build service area polygons, in this case for a 0.2 of a kilometer. I build 2 polygons for each substation, 0.2 of a kilometer, which would be walking distance of a public toilet, 1 kilometer if they had to drive to that public toilet, which would be a reasonable drive time if you just needed to take a bio break. And then we're going to match the public toilets that we're reading in from that XML file coming in here to those service area polygons, and we're going to find out whether any public toilets are within range of that data set. If there are some public toilets within range, we can use another web services call, again using ArcGIS Online, but any other tool. I know what used to be Navtech are now here also have these online services where you can do routing or drive time analysis. So if you were a subscriber to those services, you could build a custom transformer that would access those as well. But so this is the ArcGIS Online routing tool that will give us the route. And then at the end of this workflow, what I'm doing is building a table. One of our colleagues, Iris Katowski, built a custom transformer for building simple tables in FME, and then that's going out to a PDF templater and the PDF writer. So we can run this little workflow and hopefully have a look at the results. And again, this would be a great target for FME server because we can read the Smallworld database now without having to have the JS client running, and we can then have a self-serve kind of website where people could search for public toilet near Cambridge electric facilities if we wanted to. And I know we're a little bit over time, but which always upsets our webinar organizer Stephanie a little bit, but let's just have a quick look at those results that we've created there. So there's the resulting PDF file. It's got the drive time polygons. I don't know why I've chosen dull green for all this stuff, but there we have it. And so we've got the drive time polygons, the locations of the public toilets. I forgot to put in the location of the substations, but obviously they're at the center of these drive time polygons and the walking time polygons. And for the 2 public toilets that are within driving range, we've got the routes there. And then a list of public toilets that are kind of nearby in a little table format.
That's great. A fun example of what you can do with some FME technology.
Right. Yeah, and of course that could be some more serious kind of analysis, looking at properties in that are close to somewhere where you're going to do some work that might need you to tell those property owners that activity is going on or something like that.
Yeah. All right.
Okay,
so
well, I think that's it for the demos.
Yeah, thank you very much, Mark. That's a lot of great information there, a lot of wonderful examples of what we can do with FME and Smallworld. And I hope people in the audience there really got an idea of some of the things they could be looking into and doing, and have lots of energy now to to investigate some of that. So just to touch on training, we've got a couple of training coming up later this month. FME Desktop, August 19th and 20th. This is free training, so please check out safe.com and look out for your training link, and then you'll be able to sign up there. We also have Advanced FME Desktop coming up at the same dates, I guess, going side by side. That's an interesting one. We're also doing the Smallworld.
I think those dates are wrong, actually, so we should check that. They are later in the month.
Yeah, might want to go online to safe.com/training. And also, we have a Smallworld training session coming up this fall. We don't have a date set yet, but that's just keep checking out on that our website, and you'll find that information. We have, I guess, Mark, the next slide there. We've got a couple of new adventures coming up. August 26th, we're going to be doing spatial database tips. Robin and myself are going to be doing that. And a little bit later on in September, we're going to have another webinar, MicroStation DGN, how to integrate CAD and GIS. So really hope that you're going to be able to take part in some of those. We should mention that there is a webinar happening tomorrow, how to develop for data transformation for FME Server. That's coming up tomorrow. It's going to be a pretty advanced technical level of FME Server, but there's possibly some people in the audience that could be still interested in that. All right, so now it's on the Q&A. We're very sorry we run over there 6 or 7 minutes.
Yeah,
but,
so we should probably skip the Q&A. Hopefully Ken and Mark have been able to keep up. If they haven't, we will answer any questions later on as an email, I think.
Yeah, that's right. We can follow up with them. We'll get a list of any of the unanswered questions or questions that need to be revisited, and we'll get back to you. Okay.
And so with that, thanks a lot to everybody for attending. Remember that you will get a follow-up email that has the link to the PowerPoints and all those workflows that we've created. And so with that, it's goodbye from me.
Yeah, and I really hope some people learned some valuable information today and are excited about FME and what you might be able to do that with your Smallworld systems. And again, thank you very much for your time, taking time out of your busy days to be with us today.